Okay, we want to talk about rescaling a graph. We're going to do that in the context of a basic function. Could use any basic function, but the x squared function is convenient. And there's some things about the rescaling that allow you to draw more conclusions to the x squared function than some of the others. So I choose the x squared function. So here is the basic squaring function, and we certainly know how to graph that. Now, we're asked to rescale the window of this function, so the x interval becomes -3, 9, and the y interval becomes -4, 12. Okay? What do we mean by that? What do we mean by the window of the graph? Well, the window of the graph is a rectangle. That, boy, I kind of missed that point, didn't I? Okay, well, it looks like I should have put 2 over here. Yeah, it looks like my graph isn't exactly symmetric, but that's okay. I get the idea. Okay, the window is a rectangle that spans the domain and the range of the function as graphed, and nothing more. Okay, so here's our window. And the window goes from x equals -2 to 2 for the basic graph. That means the window is the interval from -2 to 2, which would be written with brackets, -2, comma 2, brackets around it. That's standard interval notation that I'm using here, so you see that. Okay, and 0 to 4 for the y. The y interval was 0, 4. Now we want the x interval to become -3, 9, and we want the y interval to become -4, 12. What's that going to do to our picture? But let's look at the interval from -3 to 9, and let's go ahead and put a scale on it. Well, from -3 to 9, if we subtract -3 from 9, we get 12, or if we just count on our fingers, we can see it's 12 units from here to here. But of course, to move from one point to another, we subtract the point that we start at from the point that we end at, the coordinate of the point, and we get the displacement. And in this case, the displacement is 12 units to the right. Okay, so we could subdivide this interval. It's got length of 12, so we can subdivide it and get an even number, which would be 3. Now, how do you subdivide? Well, when you subdivide in 2 equal intervals, you're averaging the two numbers, the mean average. So if we add -3 to 9, we get 6, and divide by 2, we get 3. Okay? And we could take the interval from -3 to 3 and subdivide that again, subdivide it in half, and we're going to get 0. 0 is halfway between -3 and 3, which is a no-brainer, and 6 is halfway between 3 and 9. Okay, so if we rescale the x-axis, then this -2 becomes -3, and this 2 becomes 9, and we have 0 here, we have 3 here, and we have 6 here. Now we could continue marking off units and so forth, but we'll go with what we have here right now. And the thing that I'll observe is that now the y-axis, which has to be the axis for which x equals 0, is over here. It's not over here anymore. So we've got a new y-axis. Make that very straight, but hopefully you can see. Okay, there's our new y-axis. And then we rescale the y interval from -4 to 12. Well, subdividing this interval in half, we see, and I didn't hit the half very well there, but we get 4 here, we get 0 here, we get 8 here. Now let's do it a little more accurately here. So we have 12 here. We have negative 4 here. So now halfway between, which I think is more like here than it was what I did before, we don't get 0, we get 4. And we get 0 here. And we get 8 here. Meaning that the x-axis on our rescaled graph is going to have to be here. Okay, rather than our white x-y axis, we have a green x and y axis. Now, if we put these axes together, they're going to look like this, where you've got 9 here. Your halfway point would be 3. You have 6 here, and negative 3 here. So that's our new set of axes. Where's the graph? Well, now the graph is not going to appear as the y equals x squared graph. That would be here. Our new graph is going to be, well, relative to the origin, we're going to be 3 units to the right and 4 units below the origin. So that our vertex of our graph here is going to be 3 units to the right and 4 units below the origin. Here's our vertex. Here's our vertex. Here's our vertex. Okay. Then we'll have the point negative 3, 12. And I didn't put my y-axis in the right place, did I? Well, I'm going to leave that in the video, and I'm going to do this right. So I'm going to just erase this. And draw it off a bit. And now, I'm going to put my x-axis down here, negative 3 here, 9 here, 3, 6, and 0. My y-axis, you'll recall, had a window from negative 4 to 0 to 4 to 8 to 12. And it goes right through the 0 there. You know what that means. Okay, now, again, my graph is not going to look the same. The vertex, which is at the origin of my original XY system, is now 3 units to the right and 4 units below the origin of the new system. So I've got to move 3 units to the right and 4 units down. And there's my vertex. Graph goes through the point negative 3, 12. So negative 3 is here, 12 is here. The y-intercept here is the origin. So I got the point through the origin. I've got the point 6, 0. So the graph goes through the point where x is 6 and y is 0. And then through the point 9, 12, here's point 9, 12. And now I can sketch a curve. Not the best parabola, kind of missed the vertex, but you have the idea. Okay, so within this system, this graph appears where this graph was. So now if I make my original graph over here green and read everything according to the green coordinates, this graph is the same as this, except that I made, my actual drawing of the window is a little different size. But there we have it. And now this function is no longer represents the basic squaring function, y equals x squared. It represents a different function. And in fact, let's see, what is it? 12, 16, that'd be 4/3. And I believe this is the equation of the function. We'll see why this is, but we want to see the effect of this sort of simple rescaling. And the reason I do this is because we study transformations and nobody ever understands them. I'm going to see if using rescaling as a basis for transformations helps people understand transformations. And there's another kind of rescaling that's extraordinarily important that I'll show in a subsequent video.